All right, so today we're going to go over two examples in order to show how you, given the certain information you have, can prove that two lines are parallel. So for example, on this one, we are given that angle 1, 2, 3, and 4 are all 45 degrees. And just as reference, we're going to label this point A, this point B, point C, D, and E. So, just like with any proof, always our first step is given. Angle 1, 2, 3, and 4 are all 45 degrees. And we know that because that's given. Okay. Next step is, so there's no real definition or postulate other than one here. We're not given that anything's supplementary. We're not given that anything's congruent. We don't have any vertical angles, anything like that. However, if we have two adjacent angles, there's a very good chance that we're going to use angle addition postulate. Angle 1 plus angle 2, angle 1 plus angle 2, right here. Those two angles added together equal angle ABC. Again, how do we know that? Angle addition postulate, or small plus small equals whole. Okay, and we can do the same thing for angle 3 and 4. Same exact thing. Okay, now that we have that, we've used our definition or postulate, there's a very good chance we're going to plug stuff in now. So when we do that, I go 45 plus 45 because that's what angle 1 and 2 are, 45 and 45. So this 45 degree angle plus this 45 degree angle equals that whole angle. And again, how do I know that? By substitution. And I can do the exact same thing for this angle. So I'm going to say 45 plus 45 equals angle EDC. For the same reason, by substitution. Now, if I put those together, if I take angle ABC plus angle EDC, add those all up, that's going to be 45 plus 45 equals those two added together. So when I do that, I get 180 equals angle ABC plus angle EDC, because both of those are 45. So it's going to be 45 plus 45, which is 90. 90 plus 45, which is 90 again. These 45s, when I add those all up, I get 180 equals those two added together. And we're just going to call that substitution / simplify, because we added 45 4 times to get 180, and we just substituted those values in. Now, if this angle plus this angle, if we look at it like this, make this a little smaller. Think of this, and think of that as my transversal that I just drew in. This angle and this angle are consecutive on the same side as this transversal on the inside. They're on the interior. And what do we know about consecutive interior angles? They're supplementary. Well, we just showed that when I added those up, they are in fact supplementary. So my last step is they are parallel. And how do I know that? Consecutive interior angles being supplementary implies that lines are parallel. And that's it. All right, let's look at this one. Now this is called a flowchart proof. Now this is your first taste of flowchart proofs, and it's just another way to line things up. So for some people, piecing it together, like this would look like if you were on a wall and you had sticky notes. Think of each of these as little sticky notes. This is what you'd be doing. Okay. You'd paste them up on the wall and you piece them together, and then you'd make sense of the proof. So for some people, a very structured proof makes most sense, and for others, piecing together this way makes sense. So we just want to show you both. Okay, so for this one, same thing as usual. We start with our given. It says angle 1 is congruent to angle 6. Or sorry, angle 1. Yep. Equals 62. And again, how do I know that? Oops. It's given. Okay. And over here, same thing. Angle 3 equals 118. And how do I know that? Because that's given. Now I look at my picture over here and I say, all right, what are some other relationships I know? Now you could say, well, Mr. Dorr, those two are corresponding, so they're congruent. Yeah, that's assuming that we know these two lines are parallel. But we're trying to prove they are parallel, so we can't just assume that. So we have to use something else. Well, no matter what, whether or not these are parallel, I do know for a fact that looking at those two, these two angles have to add up to 180 because they're a linear pair. So let's say that. Angle 2 plus angle 3 equals 180. And how do I know that? Because linear pairs are supplementary. Now, I'm given something, angle 3 equals 118. Anytime you're given something equals something, probably going to use substitution. So we're going to plug that in for right here. And so I rewrite that as angle 2 plus 118 equals 180 by substitution. Then I do some algebra here. So angle 2 equals 62. Oops. And I get that by subtraction. We subtracted 118 from both sides, right? I get angle 2 equals 62. Well, I see that if angle 1 equals 62 and angle 2 equals 62, what type of angles are those? Well, those are corresponding. If those two angles are in fact congruent, then we do know the lines are parallel, because corresponding angles being congruent implies that the lines are parallel, which is exactly what my reason is there. And then that's it. So those are two examples of what we call converse proofs. So before we were given that the lines are parallel and we use that to prove certain things. Now we're given other information and we're going to use that to prove that lines are parallel. So we're actually starting with the information we're given and ending with the lines parallel versus starting with the lines parallel and proving other information. So there's your two examples. And then on the next video, we're going to move on to 3.4, which is proofs involving lines being parallel, perpendicular, and proving something else about the lines given that information. Thanks, guys.